Okay, so today we'll talk about a new topic called Numpy. Now, Numpy is an extension of the data structure. Okay, um, so why do we use data structures? Data structure is used to mimic your real life situation, real life requirements, isn't it? So we have spoken about the simple variables like simple data types like integer, float, string, boolean, complex, right? And then we move to collections or data structures like list, tuple, and what else did we do? Dictionary and sets. Okay. NumPy is an extension of all those things. Now in NumPy, okay, the data that we will try to mimic or data that we'll try to store or handle is a two-dimensional data. Okay. So far we have seen only linear data. This is going to be our two-dimensional data. Okay. It looks very much like matrices. Okay. I hope everybody has done matrices before in their maths class. So we will see the matrices properties, how we implement matrices using NumPy. Okay. And then after that NumPy, we will do pandas. Okay. Pandas is like the tables that we did in database. Okay. So if you want to handle table in Python, we use pandas data frame. So data frame is like handling table. Okay. So these two things we'll do for next 2-3 days. So let's first talk about NumPy today. Okay. So NumPy, right? Now to use NumPy, you have to install NumPy. Okay. NumPy is not available in Python installations. You have to install. How do you install? You have to say pip install NumPy. Okay, you have to say pip install NumPy on your terminal. All right, clear here, right? How to install packages. Okay, so you have to go and install NumPy. So you go to terminal. Okay, you can either go to your terminal here on PyCharm. You can see at bottom center, or you can go to your command prompt. Okay, and then move to the folder where your Python is installed. Okay, just before python.exe, you have a folder called scripts. So you have to go to scripts folder, and there you have to say pip install numpy. You might have multiple Python, okay, if you're working with multiple versions, multiple virtual environment. So you have to make sure that numpy is installed in the environment in which you are currently working. Okay. Okay. It might generally what we do is we install in numpy at in wrong not wrong, but in different environment, and you're working in a different environment. Okay, so there you'll see when you say pip install, it will say successfully installed. But when you come back here, you know your program will say numpy not found, right? You go back and again try to install, it will say, okay, all requirements satisfied. But again, here you see that in program that it is not able to recognize. It's because you have installed in the wrong folder. Okay, you have installed in the wrong path. So you have to install in the correct path. How do you know what is the correct path of your program? Okay, if you run this program in PyCharm, okay, you'll see this. This is your correct path of Python. Okay, so you have to go to this folder here. Sorry, you need to go to this folder here, and here you install your Python. If you install it here, that's when this particular program will be able to access NumPy. Okay, so you have to install NumPy before using it. So after installing NumPy in the program, you say import NumPy. Okay, so to indicate that we are using NumPy. Now, as I said, NumPy is used to create structure like a matrix. Okay, so matrix is again two-dimensional, right? You have rows and columns. So let's first create our first NumPy object. Okay, how do we create our first NumPy object? So we'll take nums, okay, numbers equal to range of 16. Okay, so range of 16 will give us what? 0 to 15. Exactly. Okay, range will give us one-dimensional values. Okay, 0 to 15. So the nums, okay, is a normal object, or is a range object with 0 to 15 values. Now to convert into numpy, we'll use a numpy function called reshape. Okay, so we'll say again nums equal to numpy. Okay, it has a function called reshape. So reshape, as the name suggests, it will reshape that one dimensional, okay, into two dimensional. So I'll say reshape what? The nums, okay? And now you print nums. This is one way of, I'll show you other ways of getting values, but this is one way of getting values, okay? Now, when you say reshape, you have to also give the shape, right? What
Yes.
shape you want, right? So nums, okay, you are reshaping num, but in what shape? So 0 to 15, that means we have 16 elements, 16 numbers we have. Now 16 numbers can be reshaped into 2 by 8, 1 by 16, right? 1 by 16, 16 by 1. What is the difference between 1 by 16 and 16 by 1? First reference is always for rows. So when I say 1 by 16, I'm talking about a matrix with 1 row and 16 columns. When I say 2 by 8, I'm talking about 2 rows and 8 columns. If I say 8 by 2, I'm talking about 8 rows and 2 columns. The first number that we refer is rows, and second is column, row, column, RC. Okay, remember that way. It's always we refer rows first, then columns. Okay, so here we can make 4 by 4. Now see, if I try to make something different, which is not required, okay, 5 into 3. Now, first reshape takes two parameters. One, first is your number, set of numbers, and second is the shape in which you want to reshape. So if I say 5 into 3, and now I try to print num, okay, what happened? Cannot reshape array of size 16 into shape 5 into 3. So you have 16 elements and I'm trying to reshape into 15. So you cannot, right? So it has to be perfect, right? 16 can be reshaped only 16 in only. So that's why we should say 4 into 4. If you try to do 5 into 3 less or more, it's not going to get reshaped. Okay. So you have 16 elements, so you have to make it 16. So you can say 8 into 2, okay, or you can say 4 into 4, or 2 into 8, or 16 into 1, or 1 into 16. Let's try to do this. See here. Okay, see, this is your elements reshaped as 8 rows and 2 columns, right? You have 8 rows and 2 columns. The number you see, it is going by row 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to 15. And here I'm reshaping it to 4 by 4. See here,
Yes.
0, 1, 2, 3, 4. So 4 columns, and then you have 4 rows here. Okay, so this is how your NumPy will look like, matrices. Now, if you see here carefully, it looks like a list of list, right? This is your outer list, right? Square bracket. This is your outer list, and each of these are inner list. Now, only difference between this one and the list of list is that there is no comma here, right? There is no comma because it's a NumPy, it's a matrix. Okay, and the format that this is how we generally write matrix also in mathematics, correct?
Yes.
Isn't it? So this is how, if you have to use something like matrices, this is where we use NumPy. Now, if you want to see the shape of any matrix, let's say you have nums. I want to see what is the shape. Okay, so you will say shape equal to you have nums, right? Nums dot shape. Okay, shape is a variable, and when you run it, see, it says 4 by 4. So this is how you can measure shape of any value. Now see here, shape is giving us what? A numpy. Shape is giving us numpy, isn't it? Now, if I want to know only rows, how will I do? This is a numpy. Sorry, what am I saying? This is a tuple. I'm still half asleep. This is tuple, isn't it? Simple
Yes.
bracket. Okay. So this is tuple. So if I need to know the first member of a tuple, what do I do? I say
The index.
square bracket 0. Yes.
Yes.
Right. So I can say something like this. I can say rows equal to, right? shape of 0. Now this entire thing is going to give us 4 by 4. If I take 0, it will give us 4. I can say something like this. I can even say, and columns equal to nums dot shape and 1. So first member. So see, rows equal to 4 and columns equal to 4. Right? So this is how you can access number of rows and columns from a given matrix. Now, how do we read the matrix? Okay, so let's say this is the nums is 4 by 4 now. I want to read 6. How do I write 6?
What's
Okay.
it?
I want to read 6. I want to get only 6 from this. This is entire thing is nums, right? Line number 7. I just want 6 from here.
Then you just say what's it called? Row 2, column 2.
Right. So how
Row
do I
1,
write here?
column 2. Yeah.
Okay. So indexing is always done using what? Square bracket, right? I told you before that, whether it is list or tuple or any future data structure we do, the indexing is always using square bracket. And see, this looks like list of lists, but this is not a double list. I mean, this is not a list. This is obviously not a list. This is NumPy. Had it been a list, we could have said something like this: print nums. Okay, so this so this entire thing is first value. So if I need this one, I'll say 0. I'm sorry, 1. 1 will give us this entire value, and 1 of 2, okay, would have given us 6, right? This in case where this entire thing was a list, but this is not a list. This is one single value, which is NumPy. So you don't say bracket here. You use only one bracket. You use only one bracket, and bracket will have comma. Before comma, you give the row reference. After comma, you give the column reference. Okay, so you can run it like this, and you get 6 here, right? So I'm saying nums first row. This is your 0th row. This is your first row and second column. 0th column, first column, and second column. Okay. I can even use negative indexing. Okay, negative indexing is also allowed. Correct. So negative indexing, if you look at, this is -3, -2, no, -4, right? -4, -3, -2. So row is -2, column is -1. Okay. Hopefully this should also give us, no, what happened? No. Didn't work. It didn't work. Oh, I didn't use num, no, here. How will it work if I give like that? Okay, I have to say nums, right? Okay, so -2, -1. Okay, this is, what did I say? -4, -4. So yeah, so this is -2, correct? And this one is -2. This is also -2, correct? No, -3.
The row will be -3, right?
Row comma column. So row.
This one -2, -3.
See, -1 means last column, right? Obviously. So -1 is last column. So we want second from here. So -2, right? So this is -2. Okay, -1. See, I did wrong counting. I did -4, -3, right? -4 starts from here. From backwards, -1. -1, -2, -3. -3, right? And this is -2. Okay. Okay. Yeah. Help me to get up from my sleep. Okay. You should catch such things, right? So of course, negative indexing starts from -1. Sorry,
Yes, sir.
-1 here.
Yes.
So this is -3 and -2. Yeah, you get 6 here. So again, you can use minus indexing. Okay. Now, if I want, okay, if I want only a row here, okay, I want this entire row. Okay, I want entire row. So I'll say 1. Okay, but if I run, will I get entire row? No. Okay. So, okay,
What?
-1 will give us entire row, right? Because first number that we give is row. So if you say nums of 1, okay, so this is 0 and this is 1, you get
Yes.
1.
Yes.
Now if I need first column, okay, so this is second row. Now I need first column. Now for column, okay, I told you second value is column, first value is row.
Row.
So I will give blank, comma, okay, 1. Now, when I say blank here, okay, it doesn't know what comes here, what should come here, right? What should come here. Now, if I give a colon, okay, now what does column indicate? Colon indicate?
Terminals.
See, before colon, it is the starting value, right? List also we did that. Okay. When you have a blank colon, it means that you are saying starts from 0th row, go up to end of the row. Only for first column. Okay. So this is how you get first column 1, 5, 9, 13. Remember list. When I
Yes.
give single colon, okay, see here it's like giving 0 to -1. Right? It's like giving 0 to -1. Okay, start from 0, go up to the last. Right? So we say, okay, colon indicates, okay, rows from 0th to n-1th. Right? This is what colon indicates. So if I need values from first column, this one, 1, 5, 9, 13, I will give colon here to indicate that row I want all the rows. Okay. So here, okay, same thing like list, okay, but you have comma here. And before comma, it is all about rows. And after comma, it is all about columns.
Mhm.
All right. So now last thing, if I need 14, what will I say?
Uh, 14. Yes. It will be
You could do 3,
3 and
2.
yes, 2.
Yeah, 0, 1. So if I do -1, I'll get this
Minus 1
entire row,
minus
right? And if I
minus
say
2.
nums, nums, okay, and -2, I will
The
get
14th one
entire column,
column. Yes.
right? So now if I do -1 -2, that's when I will
14th.
get 14, yes. Okay. So this is how you can read the value from a NumPy. Okay. Now this is about converting a range into shape. Now let's say if you want to give your own set of values, then what do we do? If you want to give your own set of values, then you need to give it in format of list. Okay. To give your own set of values, you need to provide in terms of lists. Okay, that means, okay, you can use append, and like if you want to put the user defined values, you can use empty list append, and then you can get those values. So finally your value would be like something like, okay, double list, okay, list of list. Okay, so let's say I give like this, and I give one more, let's say, and I'll give here 1, 5, 7. I'm giving some values here, 2, 4, 9. Okay, 1, 1, 3, 3, 3, 2. Okay. Now, if I convert this, I'll tell you how to convert. But if I convert this into NumPy, how many rows and how many columns will I get? This is a linear, like this is a linear structure. This is your list structure. Okay, this is what we have done before. Okay, but if I convert it into NumPy, how many rows and how many columns will we get? Okay,
3
so see
row.
here, yeah, see this inner one are your rows. This entire thing is one row. one row, one row, one row. So how many rows we have?
4,
4 rows. And how many columns we have?
3.
Yeah. Now see, if I delete 2 here, so for list, it will work fine. Okay, this is a list. Okay, it will work fine. But if I try to convert into NumPy, how do we convert into NumPy? We have a function called as array. Array is a function to convert. Okay, mostly you will use this one only. Okay, because this was just to show you how to use range, but we will be creating dynamic NumPys, and so mostly you'll be using NumPy array function to convert list into NumPy. Okay, so I will say mat1 equal to NumPy dot array, and then you pass L1. Now you will see there will be a problem here. There should be a problem. Let's see. Okay, why there's a problem?
We have
Because
only 2.
right. So for a list it's okay, but not for NumPy. Okay, so if I say 2 here, now you can see that it will get converted
Mhm.
into 4 rows and 3 columns.
Yes.
Okay, so this is how we are able to create matrix with rows and columns.
Yes. Yes.
Okay, and this is what NumPy is. NumPy is to handle data in rows and column matrix format. Okay, a couple of more things we'll do, and then the matrix operations we'll see tomorrow. Okay, what are different matrix operations? Adding, subtracting,
Adding, multiplication.
multiplication, etc. And we will see one application also of matrix. We'll try to solve linear problems. Okay, linear equation
Yes.
problems. What are
Yes.
linear
Yes.
equations?
Mm. Sorry.
You mean like 5x plus 7y like that?
What is that? Sorry, missed you.
No, like a linear like 5x plus 7y is equal to
Correct. 5x plus. Correct. Okay. So the power of x is 1, right? When it power of x, it becomes 2, then it becomes quadratic equation, right?
Yes. Yes.
Mm.
Linear
Yes.
equation is where you have x, y, or all these variables, but variables
Power
should
1.
have only
1
yes.
power.
Okay, power of 1. So you have problems like 5 years back my father was thrice of my age.
Yes. Yes. Yes.
Today it is
Exactly.
twice of my age. What is the age of me and my father? Right, something like that. You'll be
Quantitative
able to,
abilities.
right.
Mm.
So we'll solve such problems. You can solve using matrices. Okay. Okay, couple of things before we wrap up for the day. If you want to generate, okay, before that, okay, generally, okay, what we see is we are using NumPy is too big, okay. So you will see that textbook, they use NumPy as NP, okay. This is the standard way of giving alias to NumPy, okay. So now I'm saying import NumPy as NP. So now NumPy is not available to us, but instead we have to use NP, okay. So it's a normal practice to give alias to NumPy as NP, okay. Wherever you have NumPy, it becomes NP now, okay. So we'll also use NP only, okay. So now if I say print, okay, print here, I'll say NP dot ones, or let's start with zeros first. You see zeros, okay. Now 0, I give a size of 3, 3. Now when I give a size of 3, 3, I'm saying create a matrix of size 3, 3, 3 rows and 3 columns with all zeros in it.
Mm.
Okay, so it created a matrix with all zeros in it. Okay, if you want a matrix with all ones, okay, so you can say np dot ones, and you say 3 by 3. Okay, you create matrix with all ones 3 by 3. So what is the point? This is zeros. That means 0 0.0, 0 0.0, 1.0,
Okay.
1.0. So this decimal, and since it is 0, okay, it is not displaying. Okay, so when it's not displaying, it means it is 0, 1.0. Okay, now if I do for 2, what should I write? If I want all 2s?
Who's
2s? No. you have something called as full. Okay. For zeros and ones, you have ones and zeros. Okay. Zeros for zeros and ones for ones. Anything more than one, we have something called as full. Okay. So you say full, that you give the size. Okay. What should be the size of matrix, comma, what value you want to put. So if I say 3, that means size is 3, 2. So I want 2 to be given here. All 2s, right? Instead of 3.3, let's say we'll make 5 rows and 7 columns. 5, 7 means 5 rows and 7 columns.
7 columns.
So you see 5 rows, 1, 2, 3, 4, 5, and column will be 3 plus 3 plus 1, right? 7 columns. So 5 rows and 7 columns. You can give 2.0 here. Now, when you give 2.0, okay, you'll see that's similar to what we saw earlier, right? 2.2.2. That is 2.0. So now it has become a float value. Okay. If you want all 9, you just say 9. Okay. It will be all 9. So this is how you can generate matrix with all creating 7, all having same, data. We also have one more function called as I. Okay. I is to generate identity matrix. Identity matrix. What is identity matrix?
It has only zeros and ones.
Yes, it has only zeros and one, and ones will be on the main diagonal.
Yeah.
Okay. So main diagonal is this one, 1, 1, like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Okay. Now, so that's why, see, this one is extra. So identity matrix has two properties. It has to be a square matrix with one on its main, we call it as main diagonal. Okay. So you have this diagonal also, right? This is also diagonal, right? This is also diagonal. But we don't consider this, we consider this diagonal. This is called main diagonal. Okay. So first thing, it has to be a square matrix. 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6. It can't be 5, 7, right? 3, 4. It can't have 3 different number of rows and columns. So one, it has to have, it has to be a square matrix with one on main diagonal. Okay. So how do you create? You create, let's say I'll call mat1 equal to np.I, EYE. Okay. Then here you have to mention the size, how many rows and columns, right? Since it's a matrix, one number should be enough. If I say 5, okay, it is enough. And I can print this mat1 here. Mat1, and when you print it, you see, you get all, main diagonal is this one, right? See, 1, 0, 0. Yeah, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4 is 1, and rest everything is 0. Okay. Why it's called identity matrix? Because if you evaluate matrix, okay, and okay, so you will get 1. Okay. How do you evaluate a matrix? What is that called? Okay. Okay, that's again, if you get time, try to read matrix before tomorrow's class. Okay, general matrix, not NumPy. Try to learn general, NumPy. Yeah, and then tomorrow we can, implement those mathematical,
Properties.
properties using NumPy. Okay.
Yes.